hopefully by the end of this lesson, you have learned a few things about ions. So if we're looking at our group 1 elements, our group 1 elements are typically going to form a +1 charge. And the reason for that is, say we have lithium, and lithium has 1 valence electron, okay? And so everything wants to fulfill the octet rule, which means that it wants 8 valence electrons. Now, lithium has the choice to either go back to be like helium right here. If it loses an electron, it goes back to being helium, or it can gain 6 electrons to become like neon. Now, what would you rather do? Would you rather run 1 mile or would you rather run 7 miles? Most people are going to say that they would rather run 1 mile. So lithium is going to give up a valence electron, but it needs something to give that valence electron to. So then when you have chlorine here, chlorine has 1, 2, 3, 4, 5, 6, 7 valence electrons. So it has 7 valence electrons and it wants to fulfill the octet rule as well, because everything wants these 8 valence electrons, because the 8 valence electrons means it's like you've attained stability. So what lithium is going to do is lithium is going to give up its valence electron. So now lithium has, technically it has 2, but lithium, we're going to show it as not having anywhere right now because it's lost that 1. So now it has more positive charges in the nucleus than it has negative charges around the nucleus. And then chlorine becomes chloride because as it becomes a negative charge, it drops the INE and becomes IDE. And chloride has a -1 charge. So now you have 2 components that are attracted to each other. You have positive and a negative charge. And like we've talked about before, opposites are going to end up attracting. So you have a strong electrostatic force in this case. Okay, so that's just kind of a summary of Lewis dot structures and valence electrons. So if I look at our valence electrons, here I'm going to have 2 valence electrons. And then when I jump over to boron, boron is group 13, or sometimes it's indicated as 3A. So that's going to have 3 valence electrons, 4 valence electrons, 5 valence electrons, 6, 7, and then the best, most stable 8 right there. The only exception to that, obviously, is helium. Helium has a maximum of 2 valence electrons in its valence shell. So if I looked at something like magnesium and chlorine, magnesium actually has 2 valence electrons to give. And chlorine still has its 7, so it still only wants to take 1 valence electron, right? And so what actually ends up happening is magnesium is going to give up 1 valence electron, but then it still has another one to give. And now this give and take has to happen at the exact same time. So chlorine, a new chlorine, is going to come up and be like, hey, I hear you're giving away free electrons. And magnesium is going to go, yep, I would like to give you my valence electron. And so now for every 1 magnesium, I end up having 2 chlorines. And that's how I start to form my ionic compounds, is I have to figure out how many valence electrons I have to give up and how many spots I have to take. And then I go from there. Now, another thing I would like for you to know from this lesson is hopefully you've learned that you've recognized that metals tend to give up electrons, so they form positive charges. So like everything in group 1 is going to tend to form a +1 charge. Group 2 will tend to form a +2 charge. And then boron right here for aluminum, gallium, that's actually going to tend to form a +3 charge. We don't look at carbon because we're going to look at a different type of bond for that. But then nitrogen is 1, 2, 3 away. So that's going to form a -3 charge, -2 charge, -1 charge. And then we don't form a charge for our noble gases. because our noble gases are noble, they're steady, they're stable, they're not going to be reactive. Hopefully that was helpful. And if it wasn't, hopefully you can reach out during this week.